Welcome back. In this segment of the lecture, we will focus on the phenomena of gain compression. Gain compression occurs when we only have one tone fed into the system. So, if you recall, previously we derived the output of the device for the general case when the input was a sum of two tones. Here we only have one of them, so A2 equals 0, and on the other hand we will only focus on the output at frequency omega 1, right? So we only focus on this term for the particular case when A2 equals 0. So this term in here also does not exist, right? So for this particular case, what we have is that the output amplitude is something like that, or if you want, the power gain is the ratio of this amplitude squared to the amplitude of the input tone squared, right? So in general, the power gain for this case is something like that, right? Now, recall that when we described the nonlinearities, K1 was positive and K3 is negative. That means that if we increase A1 enough, this power gain will diminish, right? And this is observed in receivers. The output power versus the input power. If we plot output power versus input power in a logarithmic scale, for example, in dBm units, what happens is that the output power follows a curve like that, right? It compresses to a point. It first follows a straight line and then it starts compressing, right? And the point where the real curve and this straight line differ by 1 dB is called the 1 dB compression point. And normally people distinguish between 1 dB compression point at the output and 1 dB compression point at the input. We can derive the condition. If we know these nonlinear coefficients, we can derive the point where this 1 dB compression occurs. If this is the gain of our system, 1 dB occurs when this gain decays by 1 dB, right? That means normally, if the system would have no nonlinearity, the gain would be simply K1 squared, and the system with nonlinearity has the gain given by this equation. So the difference between these two, when this difference is 1 dB, we have the 1 dB compression point. So we have to solve this condition and see for what value of 1/2 of 1 square this condition is satisfied. And this gives us the 1 dB compression point, which turns out to be this value.